Hi, I'm Andrew, and today let's look at adiabatic compression. Adiabatic means that this gas, this light blue gas, is going to be compressed without any heat transfer. At the very end, we will look at a case where we're going to add in some heat transfer, but for the data and the process of this experiment, we're going to keep the loss coefficient to 0, so there's no heat transfer. To start out, you're going to be changing the speed down to slow, and you're going to be varying these and seeing how it changes as you compress and change the speed and change the type of gas. So as you can see, it's compressing fairly slow, but if we take a close look at it, now that it's done, if we take a close look at it, the data actually has times 10 to the 3. And so this whole compression, even though it happened really slow, it actually happened very quickly, like 1 millisecond to fully compress. Then you're going to change the speed to maximum and double check to see how everything looks. When you take data, you're just going to go ahead and hit reset, and you're going to choose a type of gas, and I'm going to go ahead and hit compress. Oops. I'm going to go ahead and hit reset. I'm going to hit play, and then I'm going to go ahead and hit compress. And I'm going to watch it go, and then I'm going to hit pause. And don't worry about my little refresh. You're not going to have the same error. Now Command A, Control C, and then go ahead and paste it here, and I've already typed in the headers. The next thing it asks you to do is create a graph of time versus volume. Insert charts, let's make some points, and delete all the data before the before the compression starts, and all the data after the compression ends. And so if you look really carefully at this point to this point, it looks like it compresses just ever so slightly. And so I'm going to go ahead and say 2.01, and I'm going to delete everything above 2.01. Right click, delete, shift cells up, and then I'm going to go down over here, and I'm going to say 4.39 and delete down. Delete. Shift cells left, up. Okay, so now that we've edited our data so that we only have during the compression, the next thing it asks us to do is create a plot of volume versus pressure. Insert, graph, scatter. And one quick note about volume versus pressure is the area under the curve represents the work. So let's go ahead and add in some axes titles. Axes titles, and change this to pressure in PA, and change this axis title to volume. Volume in meters cubed. And was that squared cubed? All right, another quick note about this graph is typically we always think of graphs, the data going from left to right on a graph, but in this case we're actually starting over here with a larger volume and compressing it so it becomes a smaller volume. And as we compress it, the pressure increases. So if it goes from right to left, the integral, or finding the area of the chart, would be positive, but because we're going from left to right, from right to left, it's actually negative. The integral becomes negative. So work done by the gas is negative. All right, the next thing it asks us to do is create a new column, and let's go ahead and move this one over. Create a new column for the model function. Now the model function is going to be in PA, and it's a function is equal to the pressure times the volume raised to, don't forget these parentheses, raised to the power of whichever one you chose. I happen to choose 5/3 is how it calculates my my gamma, or that little squiggly character. And one quick thing is I'm going to press F4 because it's going to need those two to stay on the same one. So let's go ahead and hit F4 there, or on a Mac it's Command T. Now I'm going to go ahead and divide it by the same volume, but this time I'm not going to do F4, and I'm just going to divide it by 5/3. Don't forget the parentheses. Enter. Okay, and then I'm going to go ahead and copy this down the column. And as you can see, I went all the way down. Now to add this data in Windows and Mac looks a little bit different. And so right here, I'll do Windows first. I'm going to go ahead and select data, and I'm going to go ahead and add one. Now the series name, I'm going to call it model. The series X values is the same X values as the other set of data. Now the series Y value, I highly recommend deleting what's in there and then go ahead and select in your data. If you don't, Microsoft wants to add it in. It's a little bit weird. Okay, go ahead and hit OK. Now it added points on top of the other points. And to edit those points, I'll do, once again, I'll just keep going with Mac or Windows for just a second, and then we'll switch over to Mac. So on the orange points, we want to turn off the markers. So we do none, and then we want to add a line, solid line, and let's make the line a little bit thinner. 1 point is great. And I actually kind of like the orange that I had before, kind of a Hope College orange. Okay, great. Now the other data points, blue, blue represents the data points, and then a line is represented by a function. A function is represented by a line. So we'll make those smaller. Built in, make them smaller. There we go. There's a nice graph right there of our line. So like I said, it looks just a little bit different on a Mac. So let's go ahead and fade over to our Mac. Let's see. Is it going to pop up? There we go. Now it's popped up. I've created all the way up to pressure, and I've already included a model function. So let's go ahead, and this time I'm going to go right click or control click on the graph and select data. And like I said, the menu looks a little bit different. So we're going to go ahead and add a set of data, and we're going to go ahead and name it and just select the cell. For the X values, we're going to change the same volume as before for the X. And now for the Y, I'm going to go ahead and hit delete, and now I'm going to select our model equation and go ahead and hit OK. Once again, it added data points on top of the other data. So I'm just going to go ahead and double click on the graph, and now to select the data, I have to come up to Format and hit this drop down plot area. I'm going to go ahead and first do pressure PA, and these are the data points we want a little bit smaller. And so I'm going to go marker, marker options, built in, and let's go ahead and make them down to 2. Next, I'm going to go ahead back up to the same drop down, and I just noticed my head might be a little bit in the way of it. I'm going to go ahead and go to Model PA and go to Marker and then None. I'm going to go ahead and click Line, Solid Line, and make the line just a little bit thinner, and let's change the line to orange. So we got Hope College blue and orange. Let's go ahead and click on the graph, and my little plus doesn't add really, it doesn't say add, so I'm just going to go ahead and do chart title, above chart. I'm going to go ahead, axes titles, primary horizontal, axes titles, primary vertical, and let's go ahead and rename the first one, pressure PA. And let's go ahead and delete that. Oops, let's go back to PA, and then along the bottom, if you triple click, it selects all. Let's go volume and meters cubed. And then the chart title, let's go to, let's see, adiabatic compression. Adiabatic compression of monatomic gas. Okay, great. Now to model, let's see, to model the area under the curve, I'm going to go ahead and fade back to this graph really quick. I'm going to minus that, and I'm going to go ahead and draw a little shape really quick. Let's go ahead and insert, well, maybe I won't. I thought it'd be really easy right here oops, I didn't want to do that either. Insert some lines, but I'm not seeing it. Oh no. Okay, so anyways, let's just draw a line with the cursor. And so you can imagine a line all the way down from that point all the way down and a line all the way down. And we're going to add in little trapezoids like it shows in the discussion. Now to add those trapezoids in, we need the difference between two data points across the x-axis, and then we have to take 1/2 our position plus, so we add the two heights and we divide it by 2, and so that gives us a nice average between the two. So let's go ahead and do that. Let's go ahead and do area. And area is going to be into joules, and we're going to go ahead and equals. We're going to equals, and let's do across the x-axis first. And so we're going to do the volume minus the volume, and we're going to go ahead and multiply it by the two pressures added together, this one plus this one, and that's going to be divided by 2. There we go. Now we're going to go ahead and copy this down the column, and it does a little note. It says click on the bottom cell, and notice that is an incorrect formula, so we're going to go ahead and delete this bottom cell. We're going to just label this sum equals sum, and then we're going to go ahead and highlight all those cells. Enter. There we go. And so this would be our work in joules. Let's do joules. Now, like I said before, we have to consider whether this is positive or negative, and so we want you have to list it positive or negative based on work done by the gas, on the gas, by the piston, or on the piston. You have to choose one, state what it is, and tell me if it's positive or negative. After that, let's go ahead and rename this monatomic. Monatomic, and it looks like I'm just in the way. Monatomic. You're going to make a copy of this worksheet. Move or copy. Create a copy. And now you're going to redo the same thing with the second gas. And I'm going to go ahead and rename this adiabatic compression monatomic gas. All right, you're going to rename it. You're going to choose either polyatomic or diatomic. Diatomic. And then you're going to repeat the same process again. First looking at the volume, and you're going to cut off the edges. Then you're going to add in the data points and this curve, and then finally you're going to add in the area. Now one quick note is when you do the model for diatomic and polyatomic, it's not going to be 5/3. You have to calculate a different gamma. All right, great. Now back to the applet for just a second. Like I suggested at the beginning, you're going to repeat the process. You're not going to repeat the process, but you're going to look at it again, but this time let the coefficient equal different things. And just to show you really quick, I'm going to drag it about up to there. I'm going to go ahead and hit play. I'm going to go ahead and hit compress. Oh, it's already compressed. And I'm going to go ahead and hit expand. And as I expanded it, it dropped down, and now it's coming back to some equilibrium. And with your compression, you're going to see a similar thing. All right, that's about it for today. Thanks for watching.